Κυρίες και κύριοι, κυρία EinB TZANAKAKI. Όλο αυτό το ξεχνάω. Λοιπόν, καλή επιτυχία.
Ευχαριστώ κύριε Πρόεδρε και την Άσρη. Η παρουσίασή μου είναι στα αγγλικά, ούτως ή άλλως και οι διερμηνείς τελειώνουν τώρα. Ladies and gentlemen, my presentation is focused on a little bit of things we have been discussing, and will present the preliminary results of an intelligent energy project that has been focusing on promoting nearly zero energy buildings in municipalities across Europe. And talking about nearly zero buildings, we're focusing on what is specified by the Buildings Directive, the recast of the Energy Performance of Buildings Directive, that defines what is nearly zero energy building, a building that has very high energy performance on the one hand, and a very low amount of energy required should be covered to a significant extent by renewables, including, of course, renewables produced on-site or nearby. Now, this is a key issue because all member states need to proceed with measures at national, going down to local level, in order to have by 2019 standards, standard practice for all new buildings, including major renovations, that are nearly zero energy, and this applies to both existing buildings and new buildings mandatorily, and existing buildings going through retrofitting, and of course depends on the different building categories. A key issue, and why we're talking about, one of the reasons why we're talking about nearly zero, not net zero or plain zero energy, is the cost effectiveness issue. And it's clearly stated that a member state should not be required to set minimum energy performance that are not cost effective over the estimated economic life cycle. All these issues have been tackled already today. And we're on the road to nearly zero energy buildings, or at least we would like to be, or we would like to be in time to this. And in Greece, we already have, of course, the basic regulation existing since a couple of years ago on where all new buildings and major renovated buildings need to have a B category, a B class. But after 2003, we need to have a national plan for increasing the number of nearly zero energy buildings. And this has to do with specifications. What is a nearly zero energy building, and what are the intermediate targets? We need to achieve these targets, and then by 2021, we really need to have a major stock of nearly zero energy new and retrofitted buildings. This is what we need to do according to the Energy Performance Directive. And we do have a law in Greece that has transposed the directive, but the details have not been specified yet, so we're on the road. And we also have an incentive in our new building code that gives some promotion, some incentive, increasing the building coefficient for A+ buildings, and which is a 5% increase, and a higher percent for buildings that have very low energy consumption, which is 10% kilowatt hours per year primary energy. And the discussion, since we still do not have these specifications, and depending on the what is specified in the directive is there an optimal solution, and what may that be? And of course, requirements take into account general indoor climate conditions, avoiding possible negative effects such as inadequate ventilation, but of course, local conditions and the building function and the building age. And of course, we're talking about renewables, we're talking about efficiency measures, and there are many, many questions. Some might have partial answers, but most are open to discussion. Is there an optimal mix of energy efficiency and renewables? What are the perspectives of space heating and cooling demand in the next decades? Is there an interaction, or what is it? Is there in energy efficiency versus renewable space heating, for instance? Is there an interaction or trade-off between winter heating and summer cooling? Many several presentations focused on some of these questions today. When do we use electricity for space heating and hot water supply? What's the future? What about energy storage, and how? What do we think about CO2 emissions? What are the political decisions that need to be taken today? And what is the economic and social potential of retrofitting our building stocks for it to become nearly zero? And who can cover the costs? And to what extent can costs be covered? And of course, there's a need for policies, as we see here. There are roadmaps for changing the situation, because at the moment we're still behind. So this project, the project I'm talking about, the Affirmative Energy, Integrated Energy Design Action Project, the AIDA project, makes certain assumptions about how we can help this penetration of nearly zero energy buildings. That they should become mainstream, be well informed, to consider sustainable buildings as a matter of course. And widespread use of sustainable building technologies can be greatly accelerated if you have local seeds as starting points for technology diffusion all over Europe. This is not just in mayors that has over 400 municipalities, I think almost 5,000 municipalities all over Europe, has proved that local authorities and mobilizing local communities has a great potential in this. So what can be done to this? There is still a lack of intense actions to speed up the knowledge, and citizens should be better prepared. And of course, they will, if the public sector and mostly local authorities set an example, this would make it easier to implement. Raising awareness among local authorities and also building planners is a key factor. And we see that the more knowledge is spread, and once the main barriers are alleviated, municipalities, local authorities become more and more interested in applying nearly zero energy. And they're very proud really to participate and promote and show what they can do, and also be a role model for their citizens. However, this requires motivated town administrators, the mayors and high-level officials. The financial crisis and mission funds is a significant barrier, not only for Greece, but in most European countries. And we still don't have standards. We don't have specification at national level what is a nearly zero energy building. And municipalities usually don't set such requirements, including green procurement, which is still limited in many countries. And there are several projects taking place, but time frames are not always relevant. And of course, there's another challenge that building professionals of different specialties need to work together on a different concept of design, the integrated energy design process, which is still not very well developed in many cases and in many countries. Now, coming to just a few examples of some of the projects developed within the, followed and promoted within the AIDA project, municipal projects. One example is close cooperation with the municipality of the partner in order to have tenders for nearly zero energy buildings. This is an example of a school in Merano in Italy. And the standards for the tender set were 40% total primary energy should be from renewables, 60% of hot water supplied by renewables, 20 watts installed electric capacity by RES, and also heating demand is maximum 30 kilowatts per square meter, and there's also CO2 reduction, CO2 maximum allowed target. These are these are in primary energy, and they're only for the demand. There also have been located several examples across Europe trying to find existing applications in this direction. So exchanging experience and locating best practices has been a key target of this project. This applies to new buildings and renovated buildings. One example here is a renovated building in Kapfenberg, Austria, which has been renovated to become a plus energy building. It's a and you see there is an energy demand for heating which is very low, 11.6 kilowatt hours per square meter. There's PV systems on the roof and heating in domestic hot water supply and district heating for the residents. In Vienna, renovated to plus energy building in office building, the Vienna, the office tower of the Vienna University of Technology. Very low energy, heating energy and cooling energy demand and lighting energy demand. It's really obvious that it's really a nearly zero energy building. And the PV system is the system applied, and also there's heat pumps and district heating. The blood and tissue bank building of Catalonia. It's a new building, again with very high external insulation, reduced heat and demand, 8 kilowatt hours per square meter, 24 kilowatt hours per square meter, solar, thermal, and photovoltaic system on the roof. You will find details about these soon in the web page that I'll show you in the end of the project about all these buildings. Another school, multifunctional building, school office, workshop, dorm, and canteen in Amstetten, Austria, again with an energy demand for heating 20 kilowatt hours per square meter, and power supplied by PVs and also biomass district heating system. And yes, we also have some projects in Greece that are in the direction of becoming low energy buildings. This is a project, the Green Neighborhood, that is a project initiated by CREST, the Center for Renewable Energy Sources, in cooperation with a municipality in the Athens area, the municipality of Agia Varvara. It's the renovation of an existing social housing block. It's a pilot application of systems and technologies and user participation methods in order to achieve nearly zero energy building, including also energy management. And here we have the energy demand. This building, this project is partially implemented in one of the 4 buildings. Envelope retrofitting has been carried out, but there's still several phases of the project that need to will still take place. So now we're at the tender procedures for the overall remaining buildings. And the energy demand that has been calculated for heating is 32 kilowatt hours per square meter, Cooling demand, almost 18 kilowatt hours. There is a 76% energy saved in the existing buildings. This is a low income residence where there are very, very poor people living there. And the PVs that have been, the PVs will supply electricity and heat will be provided by geothermal heat pumps. And here we have a national in European funded project, but there has also been a private investment by energy efficient technologies. Now this is another municipal building in Loutraki. This is the building that we'll be visiting tomorrow. It's the first 100% nearly zero building that we have located. That's a standard municipal building in Greece. It's a renovation and addition to an existing building, integrating passive solar systems and also geothermal solar systems. It has very, very low energy demand for heating and cooling and very high percentage of energy saved. Geothermal heat pumps that still need to be installed because a very, very new project had just recently been completed. And there is also increased insulation in the walls. There is a green roof, external movable shading systems in the building, and it's a really nice building to visit. So if there's still someone interested in visiting this building and a couple of more other interesting buildings in the municipality, tomorrow we'll be leaving here at 9:45 from this hotel by bus and back, and everything is free of charge. So another example of a nearly zero energy building that is under construction at the moment is another renovation in the city of Thessaloniki. It's 4 school buildings with a reduced energy demand for heating, going down to 20 kilowatt hours per day, very low demand for cooling, reduced demand for lighting, and produced by renewables, which are PV systems for electricity and also geothermal heat pump. There's also building energy management systems, energy efficient lighting system, external windows, external fixed shading systems, and the energy saved from these interventions is calculated to 85% of what has been consumed now. This is calculated according of the Greek KENAK, the regulation for energy efficiency in buildings. And there are many, many other examples that are located across Europe, multifamily houses and other buildings, and a series of study tours that have taken place, trying to exchange experience. And we have municipalities visiting these buildings from various regions and various areas, and there has been a very strong interest. So we still have in this project, and we hope to have more results and some specifications about how to go through the whole process of a nearly zero energy building, not just the technical issues, but also the costs, the difficulties in the framework, how to make a tender. There are very many difficulties in the green procurement tender for a nearly zero energy building, and a lot of issues that arise in municipalities, and many issues are common across Europe. And there are some lessons learned from the experience of the first half of the project across Europe, which I'm also quoting from the project coordination, that coordinator, that the carbonization in the building sector can be achieved easily and should be realized. But it's very slow, and measures should be increased for the penetration to become more effective. There are policy measures for minimum standards and national implementation required, but we have not seen things evolving as much as it would yet, but still there's time specified in the directive. Some technical issues about combined heating in urban areas of high density that make it quite effective. And there are many links between energy efficiency and heat and electricity sector energy storage. In Denmark, we have very good examples. High potential for solar and ambient heat in near zero energy buildings due to a low flow temperature. PV is becoming, but in some cases, it sounds to be a competition between energy efficiency and renewables. This is not really a technical problem. It's more a strategic problem. It has to do with the costs and what is more promoted in things such as policies. Synergies, however, are the optimal use, and it should be very clear that we're talking about two different things. The one is a very low energy demand, a very efficient building. On the other hand, we have the renewables that will cover the load. Because when we talk about primary energy, sometimes it's a little bit confusing. We don't know what we're really talking about sometimes. And there's enormous requirements for having sustainable energy supplied. So all options are really needed, and of course, we still need to work on that. It's a long way, but we can be positive about that. And just since I've been talking about this project, I would just like to give you some details. It's a project that's coordinated by the Vienna University of Technology Energy Economics Group, and there are partners from Austria, Spain, Italy, Hungary, France, and the UK. And there's a homepage, the aidaproject.eu homepage, which is also on Facebook. And there you will find methodologies developed for energy efficiency design integrated in municipalities, and some tools about how to best implement energy efficiency measures, which are mostly focused to municipalities. And there are also examples of the buildings and best practices. So please be welcome to visit the homepage.